Welcome to Isaac Newton's third law and how to apply it in a problem. First, let's review Newton's third law. For every action, there is an equal and opposite reaction. If you look at the black box here, it's pushing against the white one, and the white one is pushing back at it with equal force. Now let's look at our problem. A spacecraft with a mass of 5,000 kilograms ejects from the International Space Station, which is a mass of about 420,000 kilograms. After 2 seconds, the spacecraft is at a speed of 7,570 meters per second. Keep in mind that the ISS normally travels at a speed of 7,670 meters per second. What is the velocity of the ISS after these 2 seconds? Before we begin, let's look at our free body diagrams. Both the spacecraft and the International Space Station are not moving up or down. Because of this, the normal force is equal to the force of gravity. However, there is the force of the ISS against the spacecraft and the spacecraft against the ISS because of the ejection. Newton's third law also proves that the force of the ISS against the spacecraft is equal to the force of the spacecraft against the ISS. This is crucial to solving our problem, as you'll find out later. Now let's look at our variables. We know the mass of both the spacecraft and the ISS. We also know that both the ISS and the spacecraft start off at a velocity of 7,670 meters per second. We know the velocity of the spacecraft after 2 seconds, but we do not know the ISS's velocity after 2 seconds, which is what we're trying to find out here. We also don't know both the accelerations, and for the purposes of this video, all vectors are set to forwards. Now, onto our solution. First, let's review our variables and what we do know and don't know. We do know the mass of the spacecraft, velocity 1 of the spacecraft, velocity 2 of the spacecraft. However, we don't know the acceleration or the force of the spacecraft. For the ISS, we know the mass, velocity 1, not velocity 2, which is the question we're trying to answer here. We don't know acceleration either, and we also don't know the force. Time for both of them is 2 seconds. So how do we approach this first? Well, we know we want v2, so we can use this equation to find v2. However, we don't know the acceleration of the ISS, which we need to use in order to find v2. Okay, well, let's see, how can we get the acceleration? Well, we can use this equation. We also need mass and the force. Okay, we have mass of the ISS, but we don't have the force. So that we get force. Well, unfortunately, that's all we can do with the ISS. If you remember about Newton's third law, F net for both of these will be equal. So if we find the F net of the spacecraft, we also know the F net of the ISS. Alright, then let's turn towards the spacecraft. Can we find F net of the spacecraft? We need mass and acceleration again. We have mass, but we don't have acceleration. Okay, well, we can use this equation this time. v2 minus v1 divided by time. And we have all of those variables, v1, v2, and time. Okay, so let's start by finding the net force of the spacecraft. First, we need to determine acceleration. Using this equation, we plug in our values for v1 and v2 as well as time. And we get negative 50 meters per second squared forwards as our acceleration. With that done, now let's find our net force. Using the equation F equals ma, we plug in our variables for mass and acceleration from our previous calculation, and we get negative 250,000 newtons forwards. Now, onto the big question. What is the velocity of the ISS after 2 seconds? To do this, we need to know acceleration first. Using this equation, we can rearrange it to find out A, acceleration, which is F net divided by mass. We already know the F net and the mass, so we just simply plug that in and get our acceleration. Now all that's left is to find the velocity. To do this, we'll need this equation. Before we can use it though, we need to rearrange it for v2. After rearranging the equation, we get v2 equals a times time plus v1. Plug our variables from here into the equation and we get our final answer, 7,671.19 meters per second forwards. Now this answer is rounded to 2 decimals, so don't be afraid that you got wrong if you had more decimals. Now we have our final answer. After 2 seconds, the velocity of the ISS is 7,671.19 meters per second. And that's all. Thanks for watching my video on Isaac Newton's third law and how to apply it in a problem.